Welcome to chemistry classes. In this video we are going to discuss about grade 9 chemistry, CBSE grade 9 chemistry chapter 2 textbook exercise. Okay, so here we have to discuss exercise 2.1. You can see this exercise in page number 15. Okay, here first question, what is mean by pure substance? What do you mean by pure substance? Pure substance means substance which contain only one type of atoms. Only one type of atoms or only one type of molecules. They have definitive proportion. They have definitive composition. Such type of substance called pure substance. Example for pure substance, oxygen or H2O. Okay, you take one oxygen cylinder, it contains only one type of atom, so it is pure substance. You take one glass of water, it contains only water, only H2O, so it is pure substance. So they have definitive proportion. Definitive proportion means in H2O always contain 2 hydrogen and 1 oxygen. One molecule of H2O always contain 2 hydrogen and 1 oxygen. They have definitive proportion or they have definitive composition. This is pure substance. Clear? And here second question, what are the difference between homogeneous mixture and heterogeneous mixture? What is the difference between homogeneous mixture and heterogeneous mixture? Homogeneous mixture, example salt water. Heterogeneous mixture, sand in water or iron powder in water. They do not mix homogeneously. They are heterogeneous mixture. So the basic difference between homogeneous mixture and heterogeneous mixture. Homogeneous mixture, particles are uniformly mixed, that is homogeneous mixture. Heterogeneous mixture, particles are not uniformly mixed. Okay, and here homogeneous mixture, they have uniform composition. When you take salt water, amount of salt in water, concentration of salt in water always same. They have uniform composition. But here heterogeneous mixture, they have irregular composition. When you take iron powder in water, you can see in the bottom part there will be much more iron powder. On the surface of water there is no more iron. Okay, so they have irregular composition. But here homogeneous mixture, they have uniform composition. Example for homogeneous mixture, salt water. Heterogeneous mixture, sand in water, or you can say iron powder in water. Clear? Okay, next one we have to discuss here exercise 2.2. 2.2, you can see this exercise, you can see this questions, you can see page number 18. Here first question again, what are the major difference between homogeneous and heterogeneous mixture? We already discussed difference between homogeneous and heterogeneous mixture. Second question here, what are the major difference between salt solution and suspension? Salt solution and suspension. Here salt, or you can say colloid. Okay, salt or colloid. The major difference between colloid, solution and suspension. So here we have to understand solution, it is homogeneous mixture. Solution, homogeneous mixture. Another two, salt and suspension, it is heterogeneous mixture. Size of particle. The particle size of solution 1 nanometer. Particle size of suspension more than 100 nanometer. Okay, here size of particles, solution 1 nanometer, and size of particle suspension more than 100 nanometer. Suspension bigger size of particle more than 100. Okay, and the size of colloidal particles between 1 to 100. Particle size of sol or colloid, size of particles 1 to 100, between 1 to 100, and the size of solution less than 1 nanometer, and suspension more than 100 nanometer. Clear? Next one we have to discuss here, Tindel effect. Next one we have to discuss here, Tindel effect. Here solution showing Tindel effect. We know Tindel effect mean when we pass light through colloid, the path of light visible. This process is called Tindel effect. Colloid or sol, they showing Tindel effect. Solution do not show Tindel effect, and here suspension may or may not be, depends on the suspension. Some suspension they showing Tindel effect, some of them do not show. Okay, so here suspension showing, some of the suspension showing Tindel effect, solution do not show Tindel effect. Clear? Next one we have to discuss here, diffusion. Solution shows highly diffusing power. Okay, diffusion through solution is very high, rapid diffusion. Okay, similarly here in colloid or sol, the rate of diffusion is very slow. Speed of diffusion is very slow in sol. Okay, suspension do not show diffusion. Clear? So diffusion not possible in suspension, and solution diffusion happen rapidly, and in sol or colloid diffusion is very slow. Clear? And here next one, stability. Here solutions are highly stable. The most stable mixture is solution, and the least stable, or here suspensions are unstable. And here we can say sol or colloid, they are stable. Okay, but they are stable than suspension and less stable than solution. Stability of sol is between solution and suspension. Stability of solution is less than solution and greater than suspension. Clear? Next one, last one here, example. Example for sol or colloid: milk, blood, smoke. These are example for sol: milk, blood, smoke. Similarly here, example for solution: salt solution, sugar solution. These are example for solution: salt in water, sugar in water. Example for solution. Similarly here, example for suspension: sand in water, muddy water, or sand in water, dust in air. It is example for suspension, not air, dust air, example for suspension. Okay, here third question, we have to calculate concentration. Okay, here it is given, to make a saturated solution, 36 gram of sodium chloride dissolved in 100 gram of water. 36 gram sodium chloride dissolved in 100 gram water. Okay, so we have to calculate here concentration. What will be the concentration of solution? So sodium chloride, that is solute. Sodium chloride, that is solute. And water, that is solvent, 100. Solution, so mass of solution 100 plus 36, 136. So we have to calculate concentration. So concentration of this solution will be mass of solute. This is the equation to calculate concentration. Mass of solute divided by mass of solution. mass of solute divided by mass of solution into 100. Okay, so here mass of solute, it is 36 divided by mass of solution, this is mass of solution 136. Do not take 100, you have to take mass of solution 100 plus 36, 136, okay, into 100. Okay, so here final answer you have to get 26.47 percentage. This is the concentration of this solution. So this is the equation, mass of solute divided by mass of solution. So don't take here 100, don't forget to take 136. We have to take mass of solution. Clear? 36 divided by 136 times 100. So concentration will be 26.47 percentage. Clear? Okay, here next one we have to discuss here exercise 2.3, and you can find this exercise in page number 24. Okay, so here question, classify the following as chemical and physical change. You have a list of changes. Okay, some changes are given. We have to classify this physical change or chemical change. To classify this, we have to understand what is physical change and chemical change. Physical change means a change by which new substance not formed. Physical change, it is temporary change, it is reversible. But chemical change, new substance will be formed. Okay, and chemical change, it is permanent change. Okay, so chemical reactions are chemical change. For example, carbon reacted with oxygen form carbon dioxide. Okay, magnesium after burn, magnesium changed to magnesium oxide. This type of changes are permanent change, they are chemical change. But similarly, melting of ice melt to water boiled to water vapor. This type of changes are physical change, physically changing. Okay, and they are temporary change. New substance not formed. Water, ice, water vapor, all are H2O. They have no chemical change. Chemically, all are same. Clear? So here, look here. First one, cutting of tree. We have to cut tree. Cutting of tree cut to small pieces. So this is physical change. There is no new substance formed. So it is physical change. Melting of what? Butter. Butter melt. Okay, so also here new substance not formed, it is physical change only. Melting of ice, melting of butter, these are physical change. Rusting of aluminium. Aluminium in presence of air and water, aluminium react and it will change to aluminium oxide. So there is a chemical change. So this is chemical change. Okay, iron after rusting it will change to iron oxide, or aluminium after rusting change to aluminium oxide or aluminium hydroxide. This type of changes are chemical change. There is chemical reaction. Clear? Next one, boiling of water boiled to steam, water vapor. This is physical change. Okay, and the next one, after passing electricity through water will change to hydrogen and oxygen. We know water means H2O. After passing electricity, water changed to hydrogen and oxygen. This process, look here, before it was water, now new substance formed, hydrogen and oxygen. So it is chemical change. So this process also chemical change. Okay, after passing electricity, water changed to hydrogen and oxygen. This is chemical change. Next one, making of fruit salad. Fruits cut into small pieces. Okay, this is happening here. So it is physical change. Last one here, burning of paper or burning of wood. I told you burning of magnesium, it formed magnesium oxide. Similarly here, after burning paper, it make new substance, some smoke, some chemicals are formed after burning paper or wood. So these are chemical change. Okay, so accordingly you can find which one is physical change, which one is not physical change. Clear? Okay, here next question. Here this is the last part of exercise, and here first question, which separation technique you will use? Which separation technique will you apply for the separation of the following mixture? Here first one, sodium chloride. You want to separate sodium chloride from sodium chloride solution. You have the mixture, you have one mixture which contains sodium chloride in water. You want to get sodium chloride. So which process you will use? We can use evaporation. After evaporation, all water will evaporate. You know, water, it's boil at 100 degrees Celsius, but the boiling point of salt more than 700 degrees Celsius. So we can use evaporation. We can use evaporation. Next one, we have another mixture which contain ammonium chloride and salt, a mixture of ammonium chloride and salt. Which process you will use to separate ammonium chloride from salt? So we can use here sublimation. We know ammonium chloride, a solid, after heating it will change to gaseous state directly. Okay, and its boiling point or melting point of ammonium chloride is less, but sodium chloride, its melting and boiling point very high. Okay, so we can use sublimation to separate a mixture which contain ammonium chloride and salt. Clear? Next one we have to discuss. Next one we have another mixture which contain small pieces of metal. Small pieces of metal in a engine oil. Engine oil which contains small pieces of metal. How can you separate it? We can use filtration. After using filtration, we can separate small pieces of metal and engine oil. Okay. Here, question D. Okay, first question, part D. Another mixture which contain different pigments. These pigments are extracted from flower petals. From flower petals extracted different colors. These colors which contain different type of components, we want to separate each component. We know colored substance can be separated with help of chromatography. So we can use here chromatography. Clear? Next one here, butter from curd. Butter from curd. How can you separate butter from curd? We can use centrifugation. We can use here centrifugation. Okay. Oil from water. Next one, mixture which contain oil and water. We know this is immiscible mixture. There is two type of mixture we discussed already. Okay. If you did not watch theory part, watch first theory part, then you have to watch this video. Okay. So here you have one mixture of oil and water. You want to separate it. We know it is immiscible mixture. We can use separating funnel. Using separating funnel, we can separate oil and water. Clear? Next one, tea leaves from tea. Simply we can say filtration. Filtration helps to separate tea leaves from tea. Filtration. Next one, iron pin from sand. We want to separate iron pins or iron nails from sand. So we can use magnetic separation. With help of magnet, we can pick out iron pin from sand. So we can say here magnetic separation. Okay, because here iron nails, it will attract towards magnet and the sand do not. Okay. Next one here, wheat grains from husk. Wheat grain from husk, we can use here sieving. You can see here sieving. Sieving helps to separate wheat grain from husk. Okay. Next one, fine mud particles suspended in water. Small mud particles suspended in water. Okay, so this mixture allowed to stand one place. This mud particle will settle down, then we can decant this mixture. Decant this mixture means you have to pour out this water separate container very slowly, carefully. Mud particles stay one place and we can remove water, or you can say filtration or decant. Okay, so these are the different technique and these are the different mixture and their technique to separate. Clear? Okay, here next question number 3. Here a table given. In this table there are different salt, their solubility in different temperature. Okay, potassium chloride, sodium chloride, this type of different salt, their solubility at a different temperature. Here we have to answer. Based on this table, there are different type of questions. Here, first question: what mass of KNO3 would be needed to produce a saturated solution of KNO3 in 50 gram of water? We have to make a saturated solution of KNO3. This is based on first question. Okay, so here question saying we have to make a saturated solution of KNO3. Okay, KNO3 in 50 gram of water. Also here temperature is given 313 Kelvin. So you can check the table. In the table it is given at 313 Kelvin we have to add 62 gram. You can check the table. In table you can see 62 gram potassium nitrate added to 100 gram of water. 62 gram potassium nitrate added to 100 gram of water at 313 Kelvin. So here question asking for 50 gram water. What will be the mass of potassium nitrate? This is mass of potassium nitrate. This is mass of water. Okay, we have to find mass of potassium nitrate at 50 gram of water. So we can cross multiply this. Okay, so here 100 times x will be 62 times 50. Okay, 100x equal to 62 times 50. So x will be equal to 62 times 50 divided by 100. When you cancel this, here 2. 62 divided by 2, 31 gram. So we have to add 31 gram. 31 gram potassium nitrate into 50 gram of water. Clear? This one you will get from the table. 62 gram potassium nitrate you have to add in 100 gram of water. This is from the table already given. Clear? Okay, here based on this table, next question. Here a saturated solution of potassium chloride in water is made at 353 Kelvin. A saturated solution of potassium chloride made at 353 Kelvin. And this saturated solution at 353 Kelvin means very high temperature. Okay, so this hot saturated solution kept at room temperature and allowed to cool Okay, then what happened? What would observe as the solution cooled? So here a saturated solution of potassium chloride at very high temperature 353 Kelvin made, and then it allowed to cool at room temperature. Then what we can observe? This is the question. So a saturated solution, we know when we increase temperature, solubility will be increases. Okay, at a higher temperature, more salt will dissolve. When we decrease temperature, when we cool the solution, solubility will be decreases. Higher temperature, when we increase temperature, solubility increases. When we decrease temperature, solubility also decreases. So when we cool the solution, solubility of potassium chloride in water decreases and crystals of potassium chloride will be appeared in the solution. So what will be the observation? Crystals of potassium chloride will be observed because at lower temperature solubility of potassium chloride decreases. Solubility of potassium chloride decreases at lower temperature, so crystals of potassium chloride will be appeared. Okay, next question here based on the table. Next question, find the solubility of each salt. Find the solubility of each salt at 293 Kelvin. Also we have to find which salt has the highest solubility at this temperature. So at 293 Kelvin, we have to find the solubility of each salt. Solubility of each salt at 293 Kelvin. Okay, so you can check the table at 293 Kelvin. In the table it is clearly given potassium nitrate 32 gram in 100 gram. Here 32 gram potassium nitrate dissolving in 100 gram water at this temperature. Similarly, sodium chloride 36 gram sodium chloride in 100 gram water. Potassium chloride 35 gram potassium chloride 100 gram water. Ammonium chloride 37 out of 100. So here which salt has highest solubility at this temperature? 37. 37 is the highest. So ammonium chloride has the highest solubility at this temperature. Okay, here based on the table, last question, what is the effect of change in temperature on the solubility of salt? When you change the temperature, what happened to the solubility? You can check the table clearly. Here solubility of same salt at different temperature is given. When you increase temperature, amount of salt dissolving in the water increases. When you increase temperature, you can add more and more salt. Okay, so here we can say when we increase temperature, solubility of salt increases, or you can say when we increase temperature, solubility increases. Clear? Okay, next one, we have to explain following terms with example. We have to explain here first one, saturated solution. Saturated solution mean imagine take a glass of water, add sugar, shake well, add again and again more sugar, okay, shake it well. After a particular level we cannot dissolve more sugar in this. Such type of solutions are called saturated solution. Saturated solution means solution in which no more solute can dissolve at a given temperature. Such type of solutions are called saturated solution. Solution in which no more solute can dissolve at a given temperature. Such type of solutions are called saturated solution. Saturated solution. Okay. Example for saturated solution, carbonated water. Cola drinks. Cola drinks mean like soda water, that is carbonated water. Okay, carbonated water mean carbon dioxide dissolved in water at very high pressure and very low temperature. At a very high pressure and very low temperature, carbon dioxide, much more carbon dioxide dissolved in water. Okay, that is carbonated water. This is example for saturated solution. Clear? Next one we have to discuss here, pure substance. Pure substance. We know iron. When you take iron, it is pure substance. All elements are pure substance. You take only gold, it is pure. Okay, you take only water, it is pure substance. You take only carbon dioxide, it is pure substance. So pure substance means substance which contain only one type of atoms. Substance which contain only one type of atoms or only one type of molecules. Okay, here substance which contain only H2O, substance which contain only one type of molecule, or substance which contain only one type of atoms. Such type of substance are called pure substance. Example for pure substance, you can say any element. All elements are pure substance. All compounds are pure substance. Okay, only iron, only gold, they are pure substance. Only carbon dioxide, only water, only sugar, they are pure substance. Clear? Next one we have to discuss here, colloid. Colloid means it is heterogeneous mixture. Colloid means it is heterogeneous mixture. It consists of dispersed phase and dispersed medium. Dispersed phase uniformly distributed in dispersed medium. Such type of mixtures are called colloid. We know colloid, there is two parts, dispersed phase and dispersed medium. We know in solution there is solute and solvent. Similarly in colloid there is two parts, dispersed phase, dispersed medium. Okay, so here you can say colloids are heterogeneous mixture. Okay, colloids are heterogeneous mixture in which dispersed phase uniformly distributed in dispersed medium. Dispersed phase uniformly distributed in dispersed medium. That is colloid. Clear? Next one here, example for colloid, blood. Blood is example for colloid. Starch in water or starch water, it is example for colloid. Milk, example for colloid. Clear? Next one we have to understand here, suspension. Suspension, chalk powder in water, sand in water, smoke, dust air, not smoke, dust air. Okay, these are example for suspension. Suspensions also heterogeneous mixture. Suspensions also heterogeneous mixture. Particle size of suspensions are bigger, more than 100 nanometer. These particles will settle down under gravitational force. Okay. So these are the things we have to understand here: suspension, colloid, pure substance and saturated solution. Okay, here next question number 5. We have given different type of substance. We have to classify this substance. Homogeneous mixture or heterogeneous mixture. We know what is homogeneous mixture and heterogeneous mixture. So see here, soda water, it is clear water, all particles are uniformly distributed. So these are homogeneous mixture. Air, normally air, this we know here, air, oxygen, nitrogen, carbon dioxide, everything here uniformly mixed. So this is also example for homogeneous mixture. Okay, and wood particles are not uniformly mixed. Okay, different type of materials are there in wood, so it is heterogeneous mixture. Vinegar means there is acetic acid and water uniformly mixed. It is not immiscible mixture, it is mixed uniformly, so it is homogeneous mixture. Homogeneous mixture. Filtered tea. Tea, we know tea leaves are there. After filtration we will get clear tea. Okay, there is red tea, sugar, everything dissolved uniformly. Okay, so it is also homogeneous mixture. Soil, there are different type of materials are there in soil. Okay, so it is not mixed uniformly and it is heterogeneous mixture. So here these two are heterogeneous mixture, rest of them homogeneous mixture. Okay, next question. Here we have given different type of substance and we have to find which of the following are pure substance. Pure substance mean we know only one type of substance. Okay, elements or compounds are pure substance. So see here, pure substance, we know ice mean there is only H2O, it is pure substance. Milk, it is mixture, not pure substance. Iron, it is element, pure substance. Hydrogen chloride, it is compound, it is pure substance. Okay, hydrogen chloride, it is pure substance. Calcium oxide, it is compound, it is pure substance. Mercury, it is pure substance. Mercury Hg, it is pure substance. Bricks, not pure substance. Wood, not pure substance. Air, not pure substance. These are mixtures. Clear? So here pure substance, ice, iron, hydrogen chloride, calcium oxide, mercury. Clear? Here next question. How do you confirm that a colorless liquid given to you is pure water? You are given a colorless liquid. You want to confirm that it is pure water. How can you confirm that? We know the boiling point of pure water is 100 degrees Celsius. So you have to boil it, check its boiling point, and boiling point of given liquid 100 degrees Celsius showing that it is pure water. Pure water. Clear? Okay, here next question. Identify the solutions among the following. We have given different type of substance and we have to find solution. We know solution mean homogeneous mixture, not heterogeneous. Solution mean homogeneous mixture. So here we have to find which substances are homogeneous mixture or which substances are solution. So we know soda water, it is solution. Okay, air, it is solution. Sea water, soda water, it is solution. Similarly, sea water also solution. Soda water, sea water, air, these are homogeneous mixture and they are solution. Okay, when you take soda water, carbon dioxide and water uniformly dissolved. Sea water, salt and water uniformly dissolved. In air, all gases are uniformly mixed. So these are solution. Okay, so here these three solution, rest of them are not solution. Clear? Okay, here question number 9. Here question number 9. Which of the following substance shows Tindel effect? Here we have different type of substance and which of this substance showing Tindel effect? We are given salt water, milk, copper sulfate solution, starch in water. Tindel effect, we know colloids showing Tindel effect. So which of them are colloid? Milk and starch water. Example for colloid we discussed already and they shows Tindel effect. Rest of them, salt water, copper sulfate solution, they are solution, do not scatter beam of light, they do not show Tindel effect. Okay, here last question here. Classify the following into elements, compounds and mixture. Here we have different type of substance. We have to classify them elements, compounds or mixture. Okay, we have to classify them. So here we know sodium, it is element. Soy, Soil, what type of substance? Soil is mixture, heterogeneous mixture, we discussed before, mixture. Okay, and sugar solution also mixture. Okay, we had to say it is element, compound or mixture. Okay, no need to say solution or homogeneous solution, you have to say it is element, compound or mixture only. So here it is element, soil it is mixture, sugar solution is mixture, silver, Ag means silver, silver is element, silver it is element. Similarly, calcium carbonate, CaCO3 means calcium carbonate, calcium carbonate it is compound, calcium carbonate it is compound. Okay, here Sn mean tin, tin it is element, tin it is element, silicon it is element, coal is mixture, coal is mixture, air mixture, soap mixture, methane, CH4 mean methane, methane it is compound, methane it is one gas, it is natural gas, methane mean natural gas and it is compound. Carbon dioxide it is compound. Blood is mixture, blood is mixture. So these are different substance and their category. I will repeat once again. Sodium it is element, soil mixture, sugar solution mixture, silver element, calcium carbonate compound, tin element, silicon element, coal mixture, air mixture, soap mixture, methane compound, carbon dioxide compound, blood mixture. Okay, so these are the things we have to discuss in this video. Okay, so thank you for watching this channel.